Greetings everyone, I am Soundar, currently pursuing my bachelor's in Electrical and Electronics Engineering from the Coimbatore Institute of Technology. I am going to explain my concepts and my views on the weeding robot. First, the problem statement. Agriculture is one of the most monotonous works in man's history, and weeding off in agriculture is an integral part which can be replaced by robots. You can ask me why. Weeding only involves certain aspects of human senses, and those senses can be imbibed onto a robot too, so that the robot can sense which is the weed and proceed to weed off the weed. I was asked to provide you guys with a video profile of myself. Instead of providing you guys blindly with all the projects that I have done, I thought it would be nice to give you guys an idea what I intend to make at the Weederbot, and also the attributes of the Weederbot, and correlate them with my expertise. Let me explain to you guys in a systematic manner. First, what are all the activities intended to be done by the robot? As by the name we can guess, it's a weeding robot, so it has to destroy or remove the weeds. The exact mechanism is not decided yet. Some of the intended mechanisms are electrocution or cutting or plucking and stuff like that. So the primary aim is to remove or destroy the weeds, and another most important thing is that it must destroy only the weeds and not the plantation crops near it. Secondary attributes are all optional, but it's a double whammy if we have all the functionalities imbibed in a single robot. For example, we can use the robot for plowing before sowing the seeds in the plantation fields, and also we can use it to evenly distribute the pesticides and fertilizers after the sowing before the weeds grow off. To carry out the intended activities, the essential attributes are of immense importance. First, autonomous navigation. The bot must be able to navigate itself autonomously without the human help into a field and recognize the weeds, and it must destroy only the weeds. That is achieved by computer vision. Computer vision is nothing but interfacing a camera, sending inputs to the camera and receiving the inputs from the camera and processing it and finding the difference between plantation crops and the weeding crops by using a pattern matching technique. The user interface. Any robot will follow the Asimov laws, but to provide the user with 100% functionalities and his desired results, the robot must obey the user. So we have included the user interface too. For example, the user interface can have the minimum controls like the locomotion of the robot and specific activities such as plowing and spraying pesticides, etc. The battery system. For any robot to function effectively, a 100% fully charged robot is essential. As I always do, I intend to use separate batteries for the circuitry and separate batteries for the motors. Since the motors need to work in a field and do tasks like plowing and weeding out, they require high torque and low speed. For supporting such activities, we need a strong battery, so that I intend to use a lead acid battery for the motors and a LiPo battery for the circuitry. The LiPo battery, which is giving power to the circuitry, will be powered by solar energy, so that the circuitry can stay alive at any situations. This is done keeping in mind that the motors of the locomotion require high torque, and high torque requires high energy. Now I will start the projects in which I had used these essential attributes which will serve the intended activities. First was the autonomous navigation in the Weederbot. I constructed a robot called the Weederbot, which was used to serve food and beverages in hotels. It was designed so carefully that it doesn't collide with the real-time obstacles such as the human beings and also the static entities such as the tables and chairs. Computer vision, Serbot 2.0. Serbot 2.0 or service robot was a housekeeping robot designed by me, and but the version 2.0, it's an improved version. Cerbot 1.0 did not have the computer vision, whereas I included the CV in the Cerbot 2.0. I use Asus Action Pro for achieving the computer vision. Also, the computer vision can also be achieved by using a camera and signal processing Raspberry Pi. Cerbot 2.0 was able to track the house, map the house, and also to find out the area of the house so that it could effectively cover entire area of the house while vacuuming beneath it. The user interface, Chatter Sounds. Chatter Sounds was an innovative idea designed by my team for the interacting with the user and getting his inputs for improving the quality of the robot. User interface. As I said earlier, any robot becomes 100% efficient and user-friendly to the user only when he has the authority to control the robot. I designed Chatter Sounds for all of my robots with minor modifications in each of them so that the user can chat with the robot and give his inputs and feedbacks to the robot so that we can modify it for the good. Chatter Sound is actually a chatbot which has a chat-like interface where you can chat with the robot interface, and the interface, the question and answer conversations will be recorded and will be considered by us for modifications. Also, we designed applications such as voice control and motion control for the robot for controlling the robot's locomotion. Battery management system, Cerbot 1.0. Cerbot 1.0 utilized a fully autonomous battery management system. For example, it charges itself by locating the power sockets. How cool is that? We use a method called as the dead reckoning so that the bot identifies where there are sockets, and we use wireless electricity by the use of inductors for mutual inductance for charging our batteries. But for the Video robot, I would suggest that we charge the robot's motors frequently so that the robot can deliver the high torque effectively. There will be frequent feedbacks to the user's mobile phone too if the battery level drops below 20% or so, our critical level. The lithium polonium battery's critical level is 8%. So if the battery goes below 20%, the user will get a notification in his mobile phone so that he can charge it efficiently and fastly. Speaking of the secondary attributes of the robots, I have already used fragrance sprayers in the housekeeping robot Cerbot 1.0 and 2.0. So the same mechanism can be applied to the weeding robot to spray fragrance and pesticides to the crops in an even manner. The possible mechanisms for removing the weeds. Overplowing the soil supporting the weeds. Now, like all plants, the weeds also require a stable and sturdy soil to keep itself upright. When we take off the soil, the weed falls by itself. We can use secondary fittings to the robot which will help it plow the way which it goes. Next is the electrocution. Electrocution is the destruction of anything by using high voltage. We can use voltage multipliers from the DC input we have to shock and take down the weeds. Next, the use of specific portions. There are specific portions available to take off the weeds, to kill the weeds. We can use target spraying mechanism to target the weeds and destroy them. We already have sprayers in our robot to do that. Let's summarize. The duration required for me to construct a robot of this kind, which utilizes autonomous navigation and computer vision, is approximately 1.5 months to 2 months. But any product can be improved and improved and improved. And in that case, I can improve this for at least 1 to 1.5 months to bring up its efficiency and add extra functionalities. About myself, I am an ambitious bachelor's degree student of the electrical and electronics community, currently pursuing my bachelor's from the Coimbatore Institute of Technology. I Also, I'm a co-founder of a tech startup called the Serbot. Some of my projects are Serbot 1.0, Serbot 2.0, Waiterbot, Chatbot, and I have built several other competition-based robots to represent my college and my startup in several other competitions such as the World Skills and etc. Thanks for considering me.